Hello everyone, welcome to Mifratech. Today in this section we'll learn about how to build a robot using Arduino. So first we'll learn about Arduino Uno microcontroller board. So as you can see in the figure, this is the Arduino Uno microcontroller board. So this Arduino is the best board to get started with electronics and coding. So this Arduino Uno is an open source microcontroller board. It is mainly based on Atmega 328P microcontroller. So this Uno is the most robust board you can mainly starts with. So this Uno is the most used and documented board in the Arduino Uno family. So it mainly has 14 digital input or output pins, which has 6 in that 14 digital input or output pins. 6 can be used as a that is a PWM output, that is pulse width modulation outputs. In that, and it also has 6 analog inputs or output. So a 16 megahertz ceramic resonator it has, and a USB connection, a power jack, and an IC SP header and a reset button. So these are the different things present in this Arduino Uno microcontroller board, and it is a programmable, so it can be programmed with Arduino IDE, that is integrated development environment, where you can dump the code via a type P USB cable to this Arduino Uno microcontroller board from the laptop or PC. So it contains everything you needed to support the microcontroller, as you can directly connect to a computer or a laptop with a USB cable, and you can also provide power supply with a AC to DC adapter, or a battery can be used in order to provide power supply for this microcontroller board. It can be powered by a USB cable, as I told, type B USB cable, or by an external 9 volts battery, or it can also use, you can provide a supply between like 5 to 20 volts supply from the power adapter, like DC adapter. Also you can provide power supply for this microcontroller board. So if it is you can also provide get a reset button in this microcontroller board. So here mainly the Uno is nothing but in that it is a Italian word. It is nothing but is the first microcontroller board which is released by the Arduino software. So only the name given is Arduino Uno. So the Uno board and the version 1.0 of Arduino software IDE were the reference version of the Arduino. Now there are different Arduino microcontroller available, like Arduino Mega, Nano. So the Atmega 328P is the main IC used in this microcontroller board. It mainly comes with a pre-programmed with a bootloader, which mainly that allows the uploading new code to it without use of an external hardware programmer. So while the Uno mainly communicates using original STK 500 protocol. So this is the protocol used in this microcontroller board, and it differs from all the preceding boards. It doesn't have it doesn't require the use of FPGA USB to serial driver chip in order to upload code for this Uno controller board. So next we'll learn about Arduino Nano. So this is the one more microcontroller. This is Arduino Nano microcontroller board. So as you can see in the figure here, so this Arduino Nano is a small and a complete breadboard friendly board. Mainly it also developed using Atmega 320P IC, and it lacks only a DC power jacks. It doesn't have any DC power jack how it is there in Arduino Uno microcontroller board. It can be it works with a mini USB cable. Like instead of in Arduino Uno we have USB type B. Here, in order to power this or in order to dump the code for this nano microcontroller, we have to use a mini USB USB cable. So it offers the same connectivity and specification of how Arduino Uno board will do. And this Arduino Nano is equipped with 30 male input or output headers, and in a DIP 30 like configuration. So this can be also programmed with Arduino IDE software. So this board can be powered through a type B micro USB cable, as I told, or you can provide to a 9 volts battery. So the Atmega 328P provides UART communication, that is TTL, serial communication, which is available on digital. It has for serial communication receiver and transmitter pin. It has, that is pin number 0 and 1. So power supply, while developing electronic project, the main, so after choosing the right microcontroller, next thing will be the power supply. Like in order to provide or in order to develop any electronic project, providing the correct power supply for this project is very important. So there is always need of multiple output voltage power supplies. So because a different like sensors or actuators, whatever the microcontrollers you used in your project requires different power supply and ground connection. That in order to provide those power supply is very important in order to run the whole project. So power supply which output multiple voltages become very efficient, as I told. So in some cases we like if you consider a motor, DC motor may require 12 volts, but your Arduino microcontroller, if you used a nano, means it may require 5 volts only. In those cases you have to use some regulator in order to provide the regulated supply for the microcontroller board. So in order to provide the correct supply for the required for the particular equipment or like sensor or a controller is very important. So batteries also can be used in order to provide the power supply. So the batteries are like electrical storage devices that mainly store the electrical energy. So based on the project requirement, we can use different types of batteries like 3 volts, 5 volts, 9 volts batteries. So generally we'll use a 9 volts battery, and when a battery is supplying an electric power, it is a positive terminal is the cathode as a negative terminal in the anode. So this is so positive and negative terminal we have to see and give it properly to the devices. So in some cases solar panels also can be used as a like a power supply sources. So here solar panel used, so it is a photovoltaic module, as you can see in the figure here. This is the solar panel. So there will be like different types of like a different voltage of solar panels available in the market, like 6 volts, 9 volts panels. Based on the project requirement, you have to use the correct solar panel. So based on your requirement. So these solar panels you can easily simply install, and you can use an additional storage battery in order to store the energy get from the solar panels also. It doesn't require any external frame or special modifications. And next important thing is sensors. So there will be like different types of sensors which will be used for specific tasks. Based on your project requirement, you have to use a specific sensor. Like sensors are sophisticated devices. They are frequently used in order to detect and to respond to an electrical or optical signals. So these sensors mainly converts any physical parameters like temperature, blood pressure, humidity, speed, etc. into a signal which can be measured electrically. So mainly for this purpose these sensors were used, like in order to detect the temperature, in order to detect humidity, soil moisture, gas hazardous gas detection, in order to detect the object detection, distance measurement. So there are different purposes you can use different type of sensors. So based on the particular project only we have to use, like example ultrasonic sensor, IR sensor, temperature, water level sensor, gas sensor, raindrop sensor, tilt sensor, flex sensor, LDR sensors. There will be like color sensor, vibration sensor. So these are the different types of sensor which can be used for a particular project. So next we'll see how to build a robot using Arduino. So now we know some information about Arduino Nano boards and sensors, and what are the power requirements required in order to build a robot using Arduino. So now we'll have some basic knowledge about the robotics, sensor and Arduino. After that we'll build some of the example of some small robot using Arduino boards. First we'll see the obstacle avoiding robot using Arduino and ultrasonic sensor. As you can see in the figure, this is the simple obstacle avoiding robot which can be built with Arduino microcontroller and ultrasonic sensor, as you can see in the figure. Next we'll see detailedly how to build this robot. So this obstacle avoiding robot is an intelligent device. It is mainly used, what it will do means it will automatically sense when any obstacle comes its way, and it will avoid them and turning itself, and it will take another direction and it will go. Like in order to avoid the obstacle, this obstacle avoiding robot is used. So this design mainly allows the robot to navigate in an unknown environment by avoiding collisions, which is a primary requirement for any autonomous mobile robot. So the application of this obstacle avoiding robot is you can use it in different application in military organization. Also you can use in risky jobs in order to do So here mainly we are using an ultrasonic sensor in order to sense an obstacle in the path. So by calculating the distance between the robot and the obstacle, so we are going to avoid that obstacle, and it is going to take a different direction and it will move. So if the robot finds any obstacle, as I told, it changes the direction and continue moving. In this way, this obstacle avoiding robot will work. So how to build this obstacle avoiding robot using ultrasonic sensor? So before we going to build this robot, we have to understand how this ultrasonic sensor will work, and have to know how the ultrasonic sensor will calculate the measure, or how to it is detect any obstacle. We have to know that. So the basic principle behind the working of this ultrasonic sensor is mainly it is going to transmit some ultrasonic waves, and it is going to receive the ultrasonic waves after hitting an area like some obstacle. So by calculating the it is going to get to know that at what distance the obstacle will be, it is going to find. So in this way you can detect the obstacle. So the distance can be calculated using the formula. So the main ultrasonic sensor whatever used in this project will be SC SR04 ultrasonic sensor. So as you can see in the figure, this is the SC SR04 ultrasonic sensor. So it has mainly 4 pins: VCC, ground, trigger and echo pin. So the trigger pin of ST06 mainly made high for at least, so whenever you use in the program you have to made high for 10 microsecond, like in order to transmit that ultrasonic wave. So whenever the sonic beam transmitted with it mainly transmitted with 8 pulses of 440 kilohertz each. So that signal then whenever it hits a surface, and it will return back, and that will be captured by a echo pin available in this SC SR04 ultrasonic sensor. So whenever echo pin receives, so what is the time period between the transmitting and the receiving of the ultrasonic wave will be calculated. By using that only we can calculate the distance between the obstacle and the vehicle, so that it can avoid that obstacle. So the time taken, as I told, in this way it will calculate. So in order to calculate the distance, this is the formula. As you can see here, distance is whatever the time period, that is transmitting and receiving of the signal, the total time period divided by 2, and what is the speed of an air, and this is the transmitting speed of the ultrasonic wave, that is 343 meter per second. So using this formula we can calculate the distance. So how ultrasonic sensor will work, as you can see here. So it is whenever it is interfaced with Arduino. Here in this example I have interfaced with the Arduino Nano microcontroller. So whenever it is programmed, initially 10 microsecond, like 8-bit pulses will be sent. So that will through the trigger here it will send the ultrasonic waves. So whenever this wave is sent, so in this way whenever an ultrasonic wave will be sent by this trigger pin, so whenever it finds an obstacle or object, so that will be reflected back, and that can be received by this echo pin. So based on this time taken in order to transmit and receive that ultrasonic wave, so distance will be calculated. So in this way, this how ultrasonic sensor will work. So the components required for this obstacle avoidance robot will be Arduino Nano or Uno microcontroller, a SC SR04 ultrasonic sensor, and LM2910 motor driver in order to control these 2 DC motors, and 5 volts DC motors. A battery will be used in order to provide the power supply, and wheels, chassis and jumper weights. So these are the components required in order to develop this obstacle avoidance robot. So this is the circuit diagram for this project. So as you can see here, mainly I am using Arduino Nano microcontroller, and ultrasonic sensor SC SR04 is connected to this Arduino Nano microcontroller, and a 9 volts battery will be used as a power supply, and a L298N driver module in order to control 2 DC motors, and 2 DC motors connected to this driver module, and the driver module is connected to Arduino Nano microcontroller. So in this way you have to connect all the components in order to develop this obstacle avoidance robot. So after making all the connection, have to place this upon the this chassis, and we have to connect these wheels. So after assembling has been done, so this is how obstacle avoiding car or robot will look like finally. So as you can see in the picture here, so this after making all the connection, we have to code for this obstacle avoiding robot. So using Arduino IDE, we'll code in the Arduino IDE, according to how we connected each component. So after coding, we have to like define what are the pin numbers we connected to the driver module, all the SC0, that is SCSR04 ultrasonic sensor. So after making all the connection in the setup, you have to define the pin names, and in the setup you have to define which will be used as input and which will be used as output, and which will be used for the like left, which will be used for right direction in order to make the movements. So after defining all those things and writing the code, have to finally dump the code into the Arduino Nano microcontroller. So this is how a final code will look like. As you can see, the trigger pin I have connected to pin number 9, echo pin to 10 of ultrasonic sensor, and the motors, one will be used for the left, like left motor, which will another right motor. For both the motors we have to define reverse direction and forward direction pin numbers. So after that we have to write the exact code. So this is the final code will look like this. So as you can see, this code we have to dump into the Arduino Nano microcontroller. So after dumping the code, we'll provide the power supply, and the obstacle avoidance robot will work exactly how I told. So it is going to move autonomously. Whenever an obstacle is detected, it will going to take another direction and it will move. In this way the obstacle robot will work. So thank you for watching the video. Thank you.